A topic that is going to be extremely important for the rest of this course is determining ionic charges formed by elements. The way to find what charge an element forms is using our handy-dandy periodic table. So the first one that we wanted to look at was lithium. So the first step is to find it on the periodic table. And here we see it in number 3, lithium. The most important thing when looking for this is now the column number or the group number. So lithium is in group 1. Remember that elements are most stable when they have 8 electrons in their outer shell. Lithium, because it's in group 1, has 1 electron in its valence electron. So this group number for the S block, the group number is equal to the number of these valence electrons. For the P block over here, the valence electron is this number is the same as this number minus 10, or just the last number in the last digit of its number. So group 13 has 3 valence electrons, group 14 has 4, etc., etc. Okay, so let's go back to lithium. Lithium has 1. So in order to get 8, it can either lose 1 and go back along the periodic table and it will look like helium here. Or it can gain 7 to look like neon. Now elements will do whatever requires the least amount of energy. So lithium, it's easier to lose 1 electron than to gain 7, right? Because you're only dealing with the transfer of 1 electron. So what will happen is lithium will lose 1 electron. Lithium will lose 1 electron. Remember that electrons are negatively charged. So if you lose a negative charge, then you become positive. So lithium, because it loses 1 electron, will have a 1 charge. Because it's losing a negative charge, it will get a positive. So we write that lithium plus. Let's look at phosphorus. So first thing we want to do is find phosphorus on our periodic table. Here it is, number 15. It's in column 15, which means that it has 5 valence electrons. Again, the goal is to get to 8 valence electrons, so it can either lose those 5 and go back down here to look like neon, or it can gain 3 electrons to look like argon. Since 3 is less than 5, it will gain 3 electrons. So phosphorus will gain 3 electrons. So we write its symbol. Now if it's gaining something with a negative charge, it will become negative. Since it's gaining 3 of them, it will become negative 3, have a negative 3 charge. So phosphorus is P3 minus when it's in its ionic form. Alright, let's try iodine. So first we find iodine on our periodic table. Here it is, number 53. This is in row 17. Since it's in row 17, that means that it has 7 valence electrons. It's just like with phosphorus, it's easier for it to gain 1 electron to get to 8 than to lose 8 electrons to get to 8. So it will gain 1 electron. If it gains an electron, which has a negative charge, it will gain a negative charge. So iodine gets I1 minus. It's easier for you to visualize it. Anything from here on over on the chart will gain electrons, meaning they will get a negative charge. Anything from here going this way will lose electrons, meaning they will get a positive charge. And then you just have to determine how much of a positive or how much of a negative charge. This row 14 right in the middle here, this one is one that we will talk about later in this course. Okay, so let's go back and look at the last couple examples that we have to do. So let's look for barium on our chart. Barium has a symbol Ba, and you'll get very familiar with finding these things on here. Ba is in group 2, which means it has 2 valence electrons. Which means it's easier for it to lose those 2 valence electrons to look like xenon than it is for it to gain 6 electrons. If it loses 2 negative charges, then it will have a 2+ charge. Let's look for oxygen. Oxygen is right here, number 8, and group 16. Group 16 has 6 valence electrons. So to go from 6 to 8, it's easier for it to gain 2 electrons. So it will gain 2 electrons, which gives it a -2 charge, so O2-. And lastly, let's look at xenon. We find xenon on our chart. It's way over here in row 18, which means that it has 8 valence electrons. Since it already has the number of electrons that every element is most stable with, that means that it does not gain or lose any electrons, and it doesn't form an ion. It's just xenon.